Hey folks, hope you guys are all well. Thank you for joining. Today I'm going to be talking about the leftmost column index of one. Now, as you can see, I'm recording at night, so been pretty crazy at work. So usually I release videos on Sundays and Wednesdays, but there's something going on at work tomorrow, which might take me out of commission all day. So I'm just trying to kind of honestly like cram all the videos and the video for tomorrow and tonight. So I might not be doing as much editing, and sorry if I'm like kind of stumbling around with words, but I think the most important thing is to keep on the schedule and keep on, adhering to schedule, keep on releasing videos on a normal cadence, and with time, the quality is going to improve. Let's get started. All right, so let's get started. So let me copy and paste the question here. Again, you can find this question on LeetCode. I came across this question before. I'm not going to say which company, but I've definitely come across this in interviews. Let me go here. Let me input the example. Okay. So, all right, leftmost column index of one. So what we're trying to do is we're given a binary matrix. So all elements are either 0 or either 1 or 1. Now, every row is sorted in ascending order, which basically means all the zeros are to the left of the ones because they're sorted. What we want to do is find the leftmost column index with a 1 in it. So what does this mean? What does leftmost column index mean? So we're given a matrix. So if you remember, a matrix is basically an array of arrays. So in this example here, we have this outer array, right? So it might be easier to actually see like this. Right? So this is like, we have this outer array that matches to these two brackets here. And within this array, this like top level array, we have a bunch of arrays within this top level array. So that's where we kind of like get the this like visual here, right? So you can imagine this kind of like it's a 2D matrix. So what does it mean that we want to find the leftmost column index? So in this 2D in this visual here, the column index is essentially the vertical index here. So like for our matrix, the 0 column index is the first column here, right? Because this is within each inner array, like an inner array is like this array and this array and this array. Within each inner array, that's what the index that points to an element in that inner array is basically the column index, because if you visually stack them up, then it looks like a column, right? So like for the first column, the index is 0. For the second column, the index is 1, right? So basically it's like within each inner array, whatever the index is, that's the column index. So we want to find a leftmost column index with a 1 in it. So visually what that means is we want to find the first column that has a 1 in it. So we can imagine, all right, let's scan from left to right, basically, right? So we start with the first column, bunch of zeros, so nothing to return there. That's not, our answer is not in this column. Second column, we look, oh, we find a 1 in it. So this is the first time when we go from left to right that we've encountered a 1 in that column. So we just output 1 in this case, right? So let's go through another example just to be safe. Or actually, this example is going to be the edge case example, where let's assume that we don't have any 1s in the matrix. If we don't have any 1s, then we just want to output -1, right? So this is just kind of how they define it in the question. Like they could have defined it as -2. Like it doesn't really matter. But for the purposes of this question, let's define if there are no 1s in the matrix, then return -1, right? And yeah, so let's get started in terms of brainstorming this. So yeah, so this question actually has, like most LeetCode questions, it has multiple ways of doing it. There's always like the brute force way, a better way, and then, maybe some other better ways or whatever. And there's like an optimal solution as well. But for this case, let's start with the brute force solution, and that's what I'm going to cover in this video, just to kind of keep things separated, and because otherwise the video is going to be super long. So we'll start with the brute force solution. So yeah, so how do we approach this question? So basically what we're doing is, visually it's easy to see. It's right, like you scan the first column, scan the second column, et cetera, until you find the first column that you're scanned that has a 1 in it, and just return that that column, right? So another way to look at this though is we can, what if we, for each inner array, or each row, as you say, let's use this as an example here. Let me zoom in here, right? So what if for each row we keep track of the first index that a 1 appears, right? So for this row here, that index would be 0, 1, 2, 3. Index 3 is where the first one appears, right? And then for the second row, 2 index is where the first one appears, and so on and so forth. 1, and here let's just define this as like -1 or something, right? Or maybe not -1, but let's define it as like a large, like none or something, right? You'll see why. So the output is 1, right? So what do you notice with the numbers that were given here, the integers that were given here, compared to 1? Well, 1 is just the result. 1 is just the smallest value of all of these indices, right? Excluding none, because none, we didn't find any 1s in that row. So with that in mind, we can kind of start to build an algorithm, which is like, we iterate through each row. We check the first, let me write this out. So basically, I'm gonna write high-level thoughts. That's what we're doing. High-level thought is and let me move this case to top because we're not really worried about this part yet. So high-level thought is basically, for each row, keep track of the left. It is leftmost, but it's also really the first occurrence of 1, right? So this is our first. This is our kind of like high level, like first approach, right? And then we want to, and say we have like a list or something, like here, like 3, 2, 1, right? We have a list of all these leftmost indices, right? And then out of all the indexes or indices, we kept track of, let me go down, return the smallest integer, right? And I say integer because here we define none as a special case where there is no 1, and so we exclude that from the results, right? So yeah, that's like, this is a pretty straightforward brute force way of doing it. Now, this would work, but there is like a bit of like an improvement. It won't really improve the time complexity much because this approach requires us to kind of go through each element, right? So assuming we can analyze the time complexity, assuming, R rows and C columns, like R number of rows and C number of columns, the time complexity is 0 of RC, because there are R times C elements, right? So like you imagine a worst case scenario, we have, a bunch of zeros. We have to iterate through each row, see every element because we're looking for that one, right? We keep looking, and because we don't see any ones, like we have to go through an entire row, right? So in this case, it's be R0 of RC. In this case, the space complexity, because we need to keep track of this list of smallest indices, or not smallest, list of first indices for each row. Let's see, how many elements do we have, right? Well, if you look at it, it's just basically, it's a number of rows that we have, right? So here we have 4 rows, 1, 2, 3, 4. So we basically have our elements that we're keeping track of, right? So basically the space complexity in this case is 0 of R because we're allocating R elements to this array or some kind of list that we're keeping track of all these leftmost indices for each row. That's fine. This way, theoretically should work. But within this, brute force solution, there's a bit of a improvement that we can make, right? And that is related to how we keep track of the smallest element, right? So basically what we're doing is we're looking for the smallest integer. And so maybe you should think, all right, let's given a, how do we improve keeping track of smallest element, smallest, let's be more specific, smallest integer, right? So, all right, let's assume that we're given list, something like this, 1 and 5 or something, right? Like, how do we know, how do we find 1, right? How do we return 1? Well, one thing to do is, we have to iterate through the list, right? So as we're iterating through the list, what if we compare each element with the smallest element up to that point, right? So let's start off at I is equal to 0. So we're looking at 4, right? So the element is, I'm going to say element is 4, right? Let's say we had, some starting minimum, right? That's we'll set it to a very big number. In this case, it's obvious, we can set it to 6 or above. So we can set it to 6, right? So in this case, when I is 0 and element is 4, we look at 4 and we can say, okay, 4 is less than 6. So we can just basically reset the minimum, right? Minimum is 4. But let's continue on. So let's say we go to I is 1 and I is 2, right? Now we do the same thing. We'll compare the global minimum, as we want to call it, we can call it, with the element, which is 2. And since 2 is less than 4, we reset the global minimum to 2, right? And so on and so forth until ultimately we're going to know that we're going to find that the minimum is going to be 1. And that's going to be returned once we reach the end of this list, right? So that's an idea we can use to kind of keep track of the minimum as we go through each of these rows, right? Because each of these rows is going to output a minimum, right? So if we use that way, we can improve the space complexity to just 1. Because what we're doing in that case is we're keeping track of just a single variable, a minimum, right? And we're not storing all of these into a list, right? I know the given in that example that we just went through, we were given in a list, but in this case, we are, it's the same thing holds. We're iterating through a given array of rows, right? Each row, right? And as we go through each row, we are comparing the global minimum with what the leftmost 1 index is at that row, right? So this will be a little more clear as we kind of code this out. So basically, we can update this part, right? out of all the index, we could return a small integer. This still holds true, but what we can do is say for each row, keep track of the first occurrence of 1. Well, let's just put this in a loop because it's going to be in a loop, right? Because we need to iterate through the rows. For each row, we can do this. We also want to do this. Compare above index with the, let's say it's called the global minimum index to be really clear, right? So, right. Awesome. So this is like pretty, I think in a good state for us to start kind of coding this. I know this is high level now. So what I'm going to do is I'm going to start implementing this. And all right, let's just call it define leftmost one. Given a matrix, right? Let me copy and paste the high level code so we can kind of fill it in as we go. Comment out. Okay, so for each row, so let's iterate through the matrix. So how do you iterate through a matrix? So basically, to iterate through a matrix, remember, a matrix is just an array of rays, right? So if you can imagine here, let's take a look at this matrix. So basically in your mind, try to picture each of these inner lists or arrays as like a single element, right? Don't let the like nested part of it confuse you too much. So like we can view it as this. So like let's say the first one is A, B, C, and D, right? So how do you iterate through this? So this is pretty straightforward, right? This is like a simple for loop. So we need there's going to be an outer loop, right? So like the first loop is the outer loop, which goes through each of these A, B, C, D, right? So let me maybe copy and paste this down here just to give like a visual, right? So for each row, so we're saying, and each row represents A, B, C, D, right? Each of those are rows. So what we're going to do is we're going to iterate through this. So for I in range length of this outer list, which is just a matrix, right? Right? And yeah, that's basically it. So like matrix at I, it represents the row, right? So when you start coding this out in interviews or whatever case you encounter needing to use this, typically you're not going to set to row, but for learning purposes, let's be very explicit in setting it to row, right? So we have a row. And what is a row? Well, if we go back up here, you remember a row is basically just an array, right? So A represents this, B represents this, so on and so forth. So a row is just basically, is a list or array, right? So we have this row, and if you remember what we're trying to do with this row, we're trying to keep track of the first occurrence of 1. So what we're going to do here is, and this is something that is generally good practice, is to, if you have like a set of instructions, which in this case is keep track of the first occurrence of 1, it's a sign that maybe you can extract those set of instructions to a new function. So just to keep things simple here, I'm going to define a new function, and let's call it find first 1, right? Okay, just make sure it's different from this name. I think that should be sufficient, right? And so we're basically given the row, we return the first occurrence of 1. So let's call it first occurrence. We're going to be very explicit in naming here, just to be clear, right? First occurrence index, right? That's all good. So now I think we just remove this just to keep it kind of clean. Right, I'm going to remove this as well because we explicitly named these variables. Okay, and then last step basically is to compare the above index, which is the first occurrence index, with the global minimum index. So one thing we forgot to do is set a global minimum index. So we need to create this global minimum index outside of this loop because it's going to be used inside this loop. So we need it to be initialized outside this loop so that we can access it, since it's going to be like reset each time we iterate through the for loop. So now it's a question of like, how do we initialize this? Well, there's always like a problem, well, not a problem, but like this little trick to, not even a trick. It's like a interesting case where, like, how do you initialize something? So in general, when you're trying to find a minimum, you can initialize like a very large number, right? Because you need to guarantee that that minimum is going to be set. Like if you set this to like, I don't know, just choose like -10, right? Since -10 is already such a small number, it's not even like an index, really in like a list. It's never really going to be set, right? So you need to set this global minimum index to a very large number, or a number that is guaranteed to be set the first time the comparison happens, so that you can override this with like the actual like index, right? So like in this case, like what's the biggest that a column can be, right? So in this case, or what's not, no, that's not a good point. Now, what is the largest that this number could be, a global minimum index? Well, if we look at go back to our picture here, the largest it can be is if 1 is like all the way to the left or to the right, right? So just to be safe, we can set this index to the size of the array, right? When the size of the array is going to like end up like out of bounds here, but it's going to guarantee that we're like setting it, right? So what we're going to do is we can set, instead of -10, set the length of matrix. Keep this part in mind, 0. Because remember, like we kind of looked at here, the length of the matrix is essentially the number of rows, but we're looking for the maximum column. So we have to go into the row. Matrix 0 is a row, remember? Like up here, A is a row. A points to this. So we have to access this row and then find the length of it, because that will give us the. All right, guys. Yeah, sorry for the cutting in and out, but my computer is low on space, so sometimes I need to clear some things out, like in between takes, which is pretty crazy. But okay, so we're back. Basically, where did I leave off? We are. Okay, we were setting the global minimum index, so we set it to the number of columns, which will guarantee that we will set the global minimum when we do the comparison. So basically, what we're doing here is we're comparing the above index, first occurrence index, with the global minimum index, right? So a trick to do this is we're basically taking, at this point in code, we're taking the global minimum index, we're taking the first occurrence index. We have two things, right? And we need to find which one is smaller, right? So luckily in Python, there's a very simple function that is called min, right? So we take min of global minimum index and first occurrence index. So one quick note, hopefully you guys can still see this. Get rid of that. So this is a little bit confusing to some people, where you see global minimum index, but you're like setting the result of this, whatever function, min function, to global minimum index. So this is a little tricky for some people starting off, but basically what you're doing is you're taking the current, remember, you don't assign it until you run an operation on it. So as you go through the loop, you find the first occurrence index, and then when you hit this line in the code, what you're doing is you're comparing first occurrence index with the global min index up to this point. And then once you take the smaller of those two, you then set it to global min index, right? So that's a little confusing for some people, but I just want to kind of like point that out. All right, cool. So yeah, basically that that is like the crutch of it. So at this point, what we want to do is we're essentially returning global minimum index, except for the case, and this is where you can start to think about like edge cases, except for the case where it's all zeros in the matrix, remember? Because if it's all zeros, we want to return -1. So in what case is it all zeros? Well, it's all zeros it's all zeros. Or sorry, what does it mean when it's all zeros? So when it's all zeros, that means that so this is going to depend on like how we implement this function, because remember, for each row we find the first one, right? So what if there is no first one? You know, what are we going to return here? So maybe to keep things consistent, you know, you can return whatever you want. It's just like up to you to define. But to keep things consistent, let's return the length of the matrix 0, or the length of each row, if there is no 1 in a row, right? Because that way we're handling things consistently. So like if we have if we have all zeros, then what's going to happen is this function is going to return the length of the row. And when we do the comparison, the global minimum index is never going to change from what it was initially set to, which is the length of the row. So basically down here, what we can do is we can say if global minimum index is length of matrix 0, we can just return -1, right? Else, that means we found a 1 somewhere in the matrix. We return the global minimum index, right? So this is one way of doing it. There's, you know, maybe other ways of doing it. Like for example, you can iterate through the matrix and see if there even is a 1 anywhere, and maybe have some kind of boolean and then work based off of that boolean, like 1 was found, and then use the logic based off of that to determine what to return exactly. But for this case, let's go with this. Okay, awesome. So let's go ahead and you know, we're almost done, except we haven't implemented this function. So what I'm gonna do is implement this as a helper function. So def find first one, let's give it a row, and what we're gonna do is let me actually returns length of row if 1 not found. Right, just to be very explicit here. So def find first one. What are we doing here? What we're doing here is looking for the first one that we encounter as we iterate from left to right in the row, right? It's pretty straightforward. So basically we need to first iterate for I in range length row, right? What's logic here? Logic is basically, since we're going from left to right, by definition, as soon as we see a 1, that's going to be the first one, because if we continue in the iteration, all the other elements are to the right of that, because we're going from left to right. So in this case, if row of I is 1, return I. Sorry, gotta think about that. Otherwise, and this is a case where we talked about down here, if there is no 1 found. So what's going to happen if there is no 1? If there is no 1, that means it never hits this condition, so it never breaks out. So we're basically checking to the end of the list. So basically, in this case, we just return the length of the row, right? Cool. So that should do it. So usually, you know, again, in a LeetCode real interview question, you want to do dry runs. But for this case, for time's sake, let's go ahead and maybe try some of these test cases here. So let me go ahead and let me copy, not copy, but these out and then move these suckers down here. And let me say matrix is this guy. Boom, boom, boom. Result. Again, we're gonna run like some kind of like, you know, simple unit test here. Oops. Like that. Type. Clack. Clackety. Result is 1. So basically what we're gonna do is run this function and compare the result. So find leftmost 1, print leftmost 1, run the function against the matrix, and see if it is equal to the result. If it is, it should return true. And similarly with this one. So in this case, fingers crossed, if we run this in the terminal, this will return 2 trues. Python main.py. Can't open file. What's going on here? Yeah, I think it's in documents actually. Okay, we have a little typo on line 3. Did I save this? I did. All right, line 50. Well, that's where it's run. This object is not iterable. Line 40. What's going on here? Oh, okay, I see. We're trying to access the element. We're not trying to call a function on row because it's not a function. Clear this out. True. Yeah, let's go. Okay, awesome. So yeah, this seems to be a working solution. All right, so this is the, like I said, this is the brute force solution. There are way better ways to do this, so we'll do those in a follow-up question. But hopefully this gives you kind of an idea of how to approach this from like a very, from a somewhat basic stance, right? And hopefully it'll pave the way to like a better understanding of how to do this more efficiently. So we'll do that in a new video. As always, comment, please. Ask any question. Give me feedback. And if you want, subscribe. That'd be awesome. All right. Cool, guys. Take care.